Hello guys, welcome to today's problem of the day. Actually, I am recording this video again. Earlier, I did some work on my notepad, and this notepad didn't get recorded. So that's that. Okay, let's get on with the problem. So this problem is longest subarray with sum divisible by k. So we are given an array, and we are given some k values. We are given a k value, and we have to tell what is the longest subarray in this, which is divisible by k. So let's see. So for example, in this subarray, we can see this 7614. This sums up to 18, and its size is 4. So this is the longest subarray in this array. Its size is 4, so its output is 4. So if we observe, we can see one thing. Like for example, let's take this array only. That's 2, 7, 6, then 1, 4, 5. Right. So if you see, this is our array, and if you like sum up all the numbers one by one and put note down the reminders, we can see one thing. Like for example, 2 modulo 3 is 2 itself. This one down here, 2, then 2 plus 7 9 modulo 3 is 0, then 0 plus 6 6 modulo 3 is 0 again, then 0 plus 1 modulo 3 is 1, plus 4 5 modulo 3 is 2, and 2 plus 5 7 7 modulo 3 is 1. So what we can see is, and initially initially always the sum of the array is 0, so we can assume like one more 0 is present at the starting of this array. So between two same reminders, we can see that always our array will be divisible by that particular k. Like between here and here, like 2 is the reminder. So these four numbers, if we sum and see, this will be divisible by 2, as we have already seen this 7614. And between this one to this one, like these two numbers, so these two numbers will 4 and 5 9 are again divisible by 3. Similarly with this 0, and we already know that there is a 0 in the starting, so these three numbers like 6 7 13 and 2 15 again are divisible by 3. Same with these two zeros, like so this particular one number will be divisible by 3. So 6 is divisible by 3. So we can see, like between two same reminders, our array is divisible by 3. And yeah, also, like one more case is there, we need to consider that, like negative numbers are also there. So what happens in the case of these negative numbers, I'll first explain you. Let's consider a small example, like -1, 8, and then 9, or 0, 9 and then 0. And let's suppose our k is equal to 9. So what happens is, like, how is this, just think of it, if it has, like, to what number is this -1 equivalent? So to what positive number? So if I add -1, if I take -1, and then suppose I have one more, I add one more number here, 1. So now if I sum of them, so what will be they equal to? 1 and 1 -1 0, and these both two numbers will be divisible by 9. So what is the positive number that I can replace this -1 with? So if you think carefully, you can just pause and think. So if you think, I can replace this -1 with a 8. So if I have 8 here, and then again I took this 1, so now this 8 plus 1 9, and this will be divisible by my 9. So this -1 is equivalent to 8. So as you can see the pattern, like we can just multiply it with -1, we'll get 1, and then subtract from 9 and we'll get or 8. So like for negative numbers, we'll have to convert it in the corresponding equivalent positive number, and then they will follow the same pattern, right? One more thing, like if instead of -1 here it would have been 10, so this -10 again is equivalent to 8. Why? Because if we add 1 to this -10, this will become divisible by 9, and the same is the case with 8. So how we can do this in this case? Like same process, but just you have to mod by 9. Like first you multiply by -1, so this -10 gets converted into 10, then you just modulate with 9, so this gets converted into 1, same number as before, and then just you subtract from 9, so this gets converted into 8. So these are the 3 steps we need to take care when we are dealing with negative numbers. So now let's write this code. So you can take a sum variable equal to 0, and you can take a map. You can take a map, or either we can take an array up to k, this of size k, that will also do. But as this we are given this k 10 to the power 9, so it might cause some issues. So we'll take just an ordered map, because all the reminders might not be there, but the range might still be large. So you can take map, and initially as 0 is already present, every empty array sub array has an sum equal to 0 in the starting, so you can just store this as -1. It will help us. Int answer equal to 0, you can take our answer variable, and then we can run a loop till n. I hope you understood this concept. If you have any doubts or clarifications, you can ask me in the comments. I tried to explain in the most intuitive way. We can add some particular element, and you can check if you can mod this first. So take like space, some mod k, and we can check if also for the negative numbers we need to check one more condition, that if our sum is negative, then what are the 3 steps I told you. First we'll multiply by this -1, we'll make it positive, and then we can take some variable here, and we'll modulo this sum with our k, and then subtract. So our final sum will be what? K minus this new number temp, right? So yeah, this doesn't change anything. This is just fine. This is for these positive numbers, like if they exceed this k, then we can bring them down till the range of k. And then if our sum exists before, find sum equal to n. So if we have not encountered this remainder before, so we'll add it to our map. And then if we have already encountered this, that means we can calculate our new answer and check if it's greater than our previous max answer. So it will be our new answer, that will be current index minus where this previous sum is stored. So yeah, like this, and finally we can return our answer. So this should work. Let's see. So oh sorry, this will be compilation error. Now it should be fine. Yeah, now it is fine. Let's try to submit this. Yeah, it is working fine. So you understood the negative. This thing is for negative numbers. Like if for negative numbers, if ever our sum goes to negative this, then you can convert it into the corresponding equivalent positive number, and then this logic will work just fine. We are just storing the first index of our this. Yeah, so we are just storing our first index of our remainder, and checking it whenever we are in, suppose 1 more 2 was there, so we are not storing this index. When this remainder came, we are checking with this one remainder, and when this came, we are again checking with this, because this will be the largest range. No need to check for this range, right? So we'll check for this range, we'll store this range. So yeah, that was it for today. If you like my explanation, please subscribe to my channel and support me. Like this video, share it with your friends. Yeah, that's it for today, and I'll try to bring more videos regularly. Thank you.